Welcome to today's TMMA Strategic Policy Forum. I'm Robert Dingus, and I will be moderating today's session. Last year, I learned of a presentation given by today's presenter, Kai-Marcel Dodel. It provided insights into China's transformative approach to automated and electric vehicle or electric freight movement. It did not take long to learn of his firsthand experiences with China's SAE Level 2 automated personal vehicles. Today's presentation will focus on automated vehicles and logistics in China. I'm going to ask that participants please type any questions that you might have into the chat box. Kai-Marcel Dodel is CEO of Connen Smart Supply Chain Systems. He served for nearly 8 years as general manager of ZF Transmissions in Shanghai, China, and also with Stihl, where he worked with logistics and manufacturing. Now, Kai, you live in Shanghai, is that correct?
I'm living in Shanghai together with my family. That's correct, yes.
That is correct. And so with that, we will turn this presentation over to Kai-Marcel Dodel. Thank you for being with us today.
Thank you, Robert, for the warm welcome, and good afternoon to the US. I'm in Shanghai. It's early morning at 5 a.m. But nevertheless, it's a pleasure to show you some insights about what's going on in China, what is the level of autonomic driving in China, and related to the logistics. Allow me first to introduce myself. So my name is Kai-Marcel Dodel. I'm from south of Germany. I do have my own company since 2 years as an entrepreneur, Connen, which I will shortly introduce you in the later slides. And beside that, I'm a member of the German Association of Hidden Champion. Hidden Champion are small, medium-sized companies which are acting worldwide in a particular field. So it's a very nice side occupation. And the last one, Novas Ventures, is helping companies from outside China to come to China to find the right location, the right operation, and also find the capital to do that. So that's what I'm doing. My expertise and hobbies, if you want to call it like this, that's new energy vehicles, the trend and future opportunity. I'm a believer in new energy vehicles. Autonomous driving, which we will learn today. I'm expert in helping struggling companies if the business is not running smooth, getting back on track. The fourth one is smart supply chain solutions, how to make a lean supply chain from the manufacturer up to the end customer. So the entire chain, manufacturing processes, leadership is a hobby to help people to grow and to lead my own team and to excellence. And as I mentioned, for Novas Ventures localization. What I'm doing right now, I'm helping a company to set up a new e-plant for motors. Okay. Now we get directly into the status in China. And I have prepared one slide with some cars currently on sale on the China market. On the left side, you can see the ranking, sales ranking of week 8, last month, February, 1 week. And the leader is not surprisingly BYD, because they have a wide range, and then following by other companies. And there's also Tesla as the only Western company still inside with on rank number 7 or 6. What we can see here, yes, Chinese companies are dominating the Chinese market. That has changed in the last 5 years dramatically. On the right side, you can see 5 brands, including sub-brand Yangwang. The first one, Haima, it's Huawei Alliance. Second one, NIO, with exchangeable batteries, BYD with a wide range of vehicles, mainly cheap and affordable, Zeekr, also a young company, 5 years on the market, Avatar, the car I'm driving, and the last one is Yang Wang, which is selling luxury cars under their BYD brand. Those are only some samples, and you can see that those 5-6 companies, they are offering around 35 cars with LiDAR on the top. The pickle on the top you will see on nearly every single picture here. As said, it's only 5 brands which are marked in red color on the left side. If you take all the brands, probably you will have more than 100 cars now sold with LiDAR. LiDAR is a synonym for autonomous driving. That means if you have a LiDAR installed, you also have the power, the CPU power, to run the car autonomously. And the LiDAR always is only the top of the sensors. Those cars on average have 24, 25 sensors inside. So that said, the current selling of the cars, and they are not yet on the market only today, they are already on the market for 5 years, some of them. The car now are ready for autonomous driving. The software needs permanent improvement, indeed. And in the introduction, you could also see one movie which I took together with Kyle in Shanghai or in Hangzhou, how to drive a car autonomously in China. And it's impressive how far we are already on level 3, level 5 approach. Okay. Important to know that in the past, companies believe that the autonomous driving will be led by logistic and public transportation companies. The reason behind this, because logistic and public transportation needs paid drivers. The vehicles naturally are more expensive. So therefore, it's more wise to first install expensive hardware on those cars because we have a return of invest. In a private car, there is no return of invest. It's only being more comfortable. But this approach obviously is wrong because we can see now the shift is autonomous driving is led by the passenger car industry. And for sure, Tesla is also a major player in this one, pushing it forward. He's a trendsetter, but others are following. So first, autonomous driving for passenger car. And in a second step, very closely, the logistic and public transportation will follow. Because they are very, very similar. And if you are able to run a car autonomously on the city of Shanghai, then a truck on the highway between New York and Los Angeles is not too difficult. Because I want to give you some insight about China, where currently I'm living, those are hot in the media for cars, which probably only few have heard of. The first one is the Maestro S800. With this car, China, Huawei is entering the super high luxury car because the price, serial price is up to 200,000 US dollar. Okay, so that's the upper segment of car. And unlike Rolls-Royce, where you have a lot of comfort and individualism inside, China is trying to gain recognition by technology. This car here is full with latest technology. On the right side, you see the i2 M9. It's the highest sales volume within luxury cars. And both have in common that they have 4 LiDARs, not 1 LiDAR, 2, 3, 4. 4 LiDARs to make sure they have really this 360-degree panoramic view to make it more safe and more reliable to go level 4. On the lower left, just on the market, a car with integrated drone in the roof. It's not a roof box, it's fully integrated into the car, With the car entertainment system, you can launch the drone with slow driving. It goes up, monitor the surrounding, and it will autonomously land in the vehicle, and you can continue to drive. And a super sports car, the Xiaomi SU7 Ultra, for only in this price segment. I mean, there is no car in the world on the street with such power. Only 75,000 US dollars. So you can see that the market is still hot in China, and that they want to convince buyers by technology. Okay, that's just some few examples. If we go to another topic, autonomous logistics, yes, there are a lot of test areas in China, mainly regional. So each region has their own test field, their own department taking care of this. And then in Beijing Central, the regulation has to be set countrywide. A big player in this market is Pony AI. And Pony AI in January got the approval to really run level 5 on public streets between the capital city and the coastal city, Beijing, Tianjin, probably around 80 to 100 kilometers. They can drive now and test their system. With one single restriction, they need a lead vehicle behind those driverless trucks. So the truck's driverless, but at the end there is one person supervising, and if something goes wrong, he is next to the spot. On the right side, Zhejiang is also trying in another region this autonomous driving, all on public roads, as said. On the left lower corner, you can see a picture of Deepway, and Deepway is a startup highly powered by Baidu, the internet Baidu. And you can see there is a tendency of similar than the semi-truck from Tesla. That is because of aerodynamic and because also in China we believe in the electrification of autonomous logistics without emissions. And Inceptio powered autonomous trucks. So there is a technology provider, Inceptio, who is enabling trucks to be autonomously driving. And level 3, level 4, they have gained in last November 200 million kilometers of real life experience. Okay, so it's not only a dream to have it in your future, it's the testing phase. And once the testing phase is done, it might roll out much faster. Now you can see Connen logo on the top. That is my company. Very short, the logistic revolution is ahead. And I'm a strong believer in this one. Otherwise, I would not run the company. And I think we all should be prepared that this revolution, not evolution, revolution is coming rather quickly. Let's start with the history. Transportation 1.0. Few hundred years ago, you used horses, buffaloes, and other ways of getting short distances to carry heavy load. Of course, we all know the disadvantages. Then the trains came to the spot, and trains now unable to go from the east to the west coast and carry heavy loads and machinery. Now, we are living in the transportation 3.0 time. That means we have trucks driving from A to B. But as you can see on the photo, and everybody's aware about this one, transportation 3.0 has endless disadvantages. It's starting with the flexibility, with the emissions they are creating, with the costs, with the time it needs, and so on. So it's a way to solve our human needs to get goods from A to B, but with a lot of negative points, side effects. And therefore, I'm a believer in this transportation 4.0, which then is 100% green, driverless, and has other advantages like electrical drive. It's faster in driving. We have a chat in the meeting. whenever you have a question, please ask them in the chat, and I'm glad to answer them as much as I can. Now let's focus on transportation 4.0. First, for the classical logistic flow, there, if you look from a bird point of view, there are 4 segments you have to pay attention on. The first one is you have the plant itself, or it could be a grocery shop in the downtown city, right? So there is some demand, supermarket or a plant, and this plant needs the goods. So you have to bring it inside the shelf, from the truck to the shelf. The second one is you have usually to drive on city and countryside roads, which have a different level of complexity. And then if you reach the highway, the motorway, then it's rather easy to go long distance. And the last one is if you have oversea or air freight or train, that's another transportation hub to overcome long distances. Okay, that's how you get goods from A to B. And if you look at the autonomous automation grade, if you want, and the green operation, we can see that the first one, the interplant logistics, so getting the component or the products, the apples from the shelf into the truck, is not yet automated. It's not yet autonomous. I'm not aware of any company who is doing this from the shelf to the truck, really free of any interaction of us human beings. So it's possible, but it's not that easy. And the second one is the city and countryside transfers. We have cars driving autonomously through the city, but we need still a driver. And that might still takes a lot of time till we can allow trucks to drive next to a public school. Therefore, it's difficult to get here the level of autonomy in the near future. The third segment, highway and long distance, it's easy. We know that Tesla in US is leading, but also Ford, GM, and so on, they are following. You can drive relaxed on a highway, on a motorway, on big roads. That is not any more difficult. It needs final optimization, foolproof, but at the end, it's possible. And the last one, we have example where the sea freight and the train transportation is already fully autonomous. One example is the port here in Shanghai, where you have basically no human anymore interfering with the container from United States. Let's go through each segment. It's a little bit technical, this slide, but it's also to understand if you want to have the entire supply chain, you have to also focus on the internal plant logistic operation. Why it's not good to have people or manual operation. The drivers, they have to wait till the factory is ready for the goods. And drivers waiting is costs. At the end, always the company will pay for the costs indirectly. If the in and outbound aren't in a defined way, then the goods will be delayed, because what has the highest priority? Always first in, first out. If you don't follow first in, first out, you will have overlaps, and these overlaps lead to complicated operation. If you worked at a big plant, you will also find that those big trucks navigating on the premises, or even a truck waiting at the family mart in downtown at the grocery, they don't make the environment more safe, and they need space. We are annoyed by waiting trucks on the public road. So, and it's difficult to supervise, because the truck driver is waiting in the truck, the forklift driver is driving around, and somebody else is writing the delivery notes, and it's not easy to operate. How to improve it? It's plant management. Plant management. The first one is you try to have inside the plant as many HEVs as possible. If you go to a grocery shop, you can even imagine of this restaurant robots, which also go to the door or to the delivery entrance. So HEV, automatic guided vehicles. And now imagine if you prepare a location mirroring the real truck, and you put everything on this location for the truck, then the copying from the ghost truck to the real truck can be autonomously. So the truck just have to arrive, and the goods, each pallet will be transferred from left to the middle, and then the truck is good to go. And it goes till its destination. And at the destination, you should have a system where you can quickly unload the truck. Therefore, the black boxes here is each box is one pallet of goods. So you make a very quick unloading of the truck. You can also operate with a ghost truck again, and then the truck is empty. Now, if you have enabled your factory on such a level, the blue truck here doesn't need a driver anymore, because the parking is defined, the process is defined, and then you can integrate even operations in the full autonomous logistic flow. Okay, it's possible, but only if those sources and destinations are prepared. As we are focusing on the trucks today on the road, the first, I call it the first and the last mile. It's from the plant to a highway, to a motorway. So this first through a city, through the countryside, it's difficult to fully make autonomously, but it's possible to electrify. There are examples available, the Tesla or the Volta CE from Sweden. There are systems available to make it fully without emission. But level 5, take the driver away. I'm not a believer in a short period. Except for small cars, small commercial vehicles are very similar to passenger cars. And we all know the hype about robotaxi, Waymo, and so on. So there is realistic that there will be such vehicles allowed, but big, large trucks, I have my doubts. Nevertheless, it can be fully electrical, and that's also a kind of revolution in the logistics. Okay, coming to the fourth segment, and that's where Connen is active. When you have long distance driving, let's take New York to Los Angeles. Usually the infrastructure is well prepared. You have multiple lanes. You might have emergency shoulder in case the truck breaks down. So you have a very good environment, and you have a very good prediction. If you look at your map application, they will show you, okay, there's a traffic jam in the middle of the way. So you have all the information able to run it in a good way. What you see in the middle is the comparison between a truck and a car. A car nowadays have 5-meter lengths. A truck has 50-meter lengths. So if you take 2 or 3 cars, you reach the same length. And if you now consider that the cars are not close to each other, but usually they have a safety distance, the complexity is far less than most people think. Especially if you go to the middle product, those autonomous transportation vehicles, because they are shorter and they have no trailer, so the behaving of those at corners is the same as a car. Why truck is more easy? Because they are rather slow on the road, right? they have a defined speed. I'm not sure about the United States. The maximum speed here in China or in Europe, it's 90 kilometers per hour. So that means if you have a slow speed, the prediction, the sensoring, the movements, everything is slow motion. Also, we all know that a truck is braking slower. So this kind of environment make it easier to get a truck autonomously driving for long distance. And indeed, what we see on the map here, that's China. If you drive from the northeast to the west, and those 3,800 kilometers, everything is defined highway. And in China, you have to pay for the highway, but it's one toll gate in Harbin, and it's another toll gate at Lhasa. In between, it is like shown one straight line with a few highway junctions, right? That you change from the M5 to the M7 highway, but at the end, everything can be easily managed. Then what do you need for level 5? Imagine you have a truck and there is no driver anymore. The truck will be significantly easier because all the truck itself is made for the people, for the operator. You have a comfortable door, you have a comfortable mirror, you have an air conditioner, you have a navigation system, a radio system. Everything you have for the truck driver is not needed anymore for non-truck driver trailers or logistic vehicles. And if you keep this in mind, then suddenly the remaining technology gets rather simple. That's where we are specialized here in making such new vehicles. Let's call them simplified skateboards, to make those skateboards safe, reliable, and fulfilling the purpose they're intended to do. And if you cut this elephant into 4 slices, you will have first a front end with all the technology inside, aerodynamic safety. Then you need to power the skateboard by an e-drive system, electrical motors, suspension. To get the power for the motors, you need power units, could be fully electrical, could be combined by hydrogen and electrical. And just as a reminder, every hydrogen truck is an electrical truck, right? So electrical truck is the basis, hydrogen is the power source, and somehow you have to link them by a frame. Now, if you have such a vehicle, you can probably already see the huge saving you will have. Saving are no driver, less costs, no driver, no brakes. Because electrical power, it will run up to the maximum speed and keep the maximum speed till the power is empty. If you have swappable batteries, which certainly will be the target, you just have to make a stop, change the battery, continue, stop, change the battery, continue. So you can plan now a distance between New York and Los Angeles by taking the distance divided by probably 45 miles as an average speed, and then you know it takes exactly 2 days to arrive. Okay, that is Logistic 4.0. And how does it work in real life? We talk about the internal plant operation. We talk about the first last miles through the city to the highway. And then once you reach a logistic hub next to such highway network, then you can switch to level 5. And then at the other side of the destination, you do the opposite. You hand over the goods to the first last mile transportation and then go inside the plant. You can link train stations with airports. You can very large companies to port. All this kind of link can be done autonomously. The difference in system, the classical way, I call it, it's you have the plant, and you have another plant, and you have to get the goods from A to B, right? Or factory, supermarket, whatever you want to call it. And then you have to usually use a driver for the entire way. And whereas within a city, it makes totally sense. If you have the interprovincial and transportation, it might not make that much sense anymore. And then it's probably better to make the second way, the Connen way, ABCD, that you have the point plant to hub. You hand over the good, the cargo, you make long distance in a very efficient, cheap way, and then at the end, at the destination hub, you make the vice versa, get the goods to a local truck and get it inside the factory. Okay, advantages, certainly much cheaper. Second advantage, and we all longing for this one, it's emission-free transportation. At the end, transportation is one of the biggest contributor to the climate change. How does it look like on China? And you can easily imagine the same with a different background. So with the United States or Europe, Africa, Australia, it's always the same principle. You define a few highways to be ready for level 5. Later we have plenty of slides explaining what does it need to be level 5. But if you have those few highways ready, then you already can link the entire continent. And here for China, 15 already very powerful. And once you have the master, you can also split it down and say, okay, but I want also smaller cities to contribute. So out of a dream, you can make a realistic plan to get it implemented. Okay. For China, it's calculated 500 inland hubs, considering United States would be roughly the same. So if you have 500 of those spots on your network, then you can get goods from everywhere to anywhere without emissions. There are threats and potential partners. It depends how you're looking at it. The classical trucks, especially for long distance, and long distance is the maturity for those trucks to exist, and they will have a challenging time because not needed anymore. The trailers itself will be also electrified in near future. So there will be chances to say, if you're in the trailer business and you are willing to go the revolution, you can electrify your trailer and your market will expand. Every trailer will be not anymore just a mechanical part, but will be including power electronics, will be a smart trailer. You can increase your business. If you miss to change from mechanical to smart trailer, of course, then the company will have difficulty to survive. For electrical trucks like the Tesla Semi, they are needed for the first and last mile, as mentioned, because the transformation in the cities takes much longer, but they will not be needed for the majority of transportation. Logistic companies, they will also probably suffer a lot, because if you have now the map with 15 hubs, the linkage between the hubs who is offering the service will be king. The one not offering the service will always be the one asking for help. Right? Whereas right now, it's a different world. So there will be big changes in this segment of logistics. I'm 95% sure. The transportation of train, yes, there are reasons to exist the trains, but at the end, if you now take the train from New York to Los Angeles, or you take an autonomous truck from New York to Los Angeles, there will be not much difference. Whereas the truck is highly flexible, because you put the goods on the C-trap, on the skateboard, and let it go. The train, you have to wait when is the next train scheduled and when the track will be empty, because always passenger trains have priority and so on. It's far more complicated to plan a container from New York to Los Angeles with a train than it would be to put the container on a skateboard and let it go. And in general, that's the same for passenger car. The last one, the petrol stations itself, they already suffering with electrification here in China, also elsewhere. They can feel those 10, 15, 20% electrification rate, but the major selling point of them is diesel to trucks. Diesel to trucks. And if this business also break apart, then of course those petrochemical industry has also something to adjust. Okay. My point of view, transportation 4.0, as I call it, is coming, and it will not come as slow as some might hope. Once it's ready, the technology, the advantages are too superior that then, of course, everybody said, okay, now if you have those skateboards from New York to Los Angeles for 60% of the price, then everybody will ask for it. Right? Once it's ready, it's a hot product, and the hot product will then challenge immediately the existing industry. Just to be prepared. And I can see a lot of opportunities, but I'm also aware that some might find it challenging. Let's get into a little bit more details. And there are 4 segments I will talk about today. The first one is intelligent connected vehicles, the artificial intelligence, AI, also for transportation and in the car industry, and the vehicle road cloud integration. So how the vehicle is communicating with the infrastructure. Highly interesting areas. And let's start with the intelligent connected vehicles. I will not overrate them too much, because as you could see already with my demo video, that autonomous driving with the existing infrastructure, it's possible. The communication with other vehicles is not adding too much value anymore, and therefore this market is growing, but probably not as important as some media is reporting about it. On the very first slide, we saw the current cars on the street. Those cars, they not only have all the sensors and the technology, but they also have the permanent internet connection. So every car which has a LiDAR for sure has a 5G connection in China. So that means all the data of the car already available. Now it's the question how to get this data to the car next to you. And there you have to filter. Do I have it here? Yeah. You have to filter the information which is really needed. Okay, not everything is needed for the next car. Technically wise, we classify them in 4 areas. The first is autonomous navigation, and there you need the AI to power it and so on, standard. Vehicle-to-vehicle communication, that this one needs to be regulated, how you transfer information. I'm aware that since many years you already have tests with same brand, BMW for example. They are testing between BMW and BMW to inform the next BMW that there's an accident, but that's a closed communication. What is needed is that BMW is communicating with Tesla, right? And this needs to be standardized. So the protocol needs to be standardized. Vehicle to infrastructure, it's the same. And depending which data are important. And the advantage is preventive maintenance. So when your car faces a problem, it will be directly sent to the cloud, and you can pre-act by making the appointment with the 5S or 4S dealer. As mentioned, it's not important that you send every single data. You don't have to send your destination to the next car following you, right? That is ridiculous. You only have to filter what is really of importance. And importance might be emergency braking, or there is a dog crossing the street, or there is an accident ahead, or suddenly we have a fog wall entering, or the road is slippery, right? Those kind of information, they are worth to send to the vehicles around and taking the same path. This filtering needs to be done, but beside those critical situations, normally no vehicle-to-vehicle communication is needed. My point of view, there might be other opinions out there as well. Some examples is given here. So if you have a medical issue and your car is stopping, of course, it would be very helpful if you send this information by bypassing vehicles, and the brave drivers then will stop and help. Yes. So vehicle to vehicle, sometimes it's necessary, but it will not be a game changer. Right? It's not depending on the revolution is not braking or slowing down because the vehicle to vehicle communication. The vehicle road cloud integration, on the other hand, has potential to enhance level 5. For level 3, you might not need it necessarily, because whenever there is a critical situation, the driver will interact, take over for 30 seconds, and then again level 3 is continuing. But if you have level 5 and no people anymore in the car, and probably no call center at the back who is remotely controlling difficulties, that means you need to communicate with the infrastructure as well. Let's take some examples. So what would be helpful for the infrastructure and for the network to run if you have real-time information of the road condition, right? Imagine you know exactly that this road is empty, safe, what is the temperature there is no snow, then you can make a navigation based on those information much more smooth. You can avoid traffic jam. You can be aware, oh, it's snowy, please, you have to consider more time and you have to drive carefully. Now, how to get those real-time information? And I'm especially thinking about at night, at the countryside, where there is hardly any car driving. Even in such condition, the level 5 should be available. And then you need the information not from the cars which are passing by, you need the car from the infrastructure. And one simple way here would be to install in a grid approach those mini sensors, the mushroom on top here, which has basic sensors inside. Basic sensors are listed here because sensors, electronics, and so on, you need a little bit of power. And you don't want to make a wiring, so you have solar panel to get the power and store it in a buffer battery. You range radar, check the environment. You check the weather condition, rain, snow, fog, the temperatures of interest, and you communicate those information via Bluetooth to the master mushroom, and let's call it like this. The picture is drawn on the lower right. That means you have slaves, simple getting the data, and then you send them at a central point, and this central point will then send the information into the big cloud. And based on this, you can monitor all the roads which might be interesting for such a supervision. Okay. The cost is not too high if you consider how much every mile of street is costing, because the sensor itself is nothing more than then a small mobile device. This mobile device already have most of the function inside, and then you get the cost down to probably $200, even half, and you have to put them every 50 meters, for example, by a pad. You will program them, and then you get the data. Okay, we are talking about the future. So in the future, where you really have a map and you get real-time data, okay, at this spot in the countryside, the temperature is 5 degrees and it's safe to drive. A little bit more complicated for this level 5 are always crossings, and every crossing has their own individualism, so they are all separate or different. You have to standardize the data you want to collect and how to transfer them. If you have those data, then you can easily make adjustment and say, okay, I will drive not with 40 miles per hour to the traffic light, but only with 30 miles, because then the driving is far more smooth. Smooth driving always will lead to less traffic jams. So they are only winners by preventive driving, predictive driving. Okay. It's a little bit complicated, but imagine you put every traffic light with a kind of sensor specific for this crossing. You might get the real crossing behaving. And if you take this real crossing behaving over a period of time, with AI, you can make prediction. And with prediction, you can make the traffic flow far more smooth and easy. Okay. Parking to grid. Once you're used to autonomous driving, as I am, you will also find out that it would be great to go to the shopping mall and leave your car there, and the car is parking somewhere else, right? And when you finish shopping, the car is coming back. The big problem is yet that the car doesn't know really where to go. Can it find the parking lot? Will it block the entire parking lot because it's searching, it's navigating, and so on? So if the car would know where to park, then the traffic flow will be far smoother. And this can be done by adding sensors to the parking spots. And again, in the cloud, you can already reserve the parking you want to go. Again, we are talking about level 5. And right now, the parking is not ready for level 5. It's somehow possible to blindly navigate through a parking lot till you find a parking, but you're not sure, is it a private parking, and how far is the parking away, and all this kind of information are missing. So for level 5, the parking needs to be upgraded. And that also needs to be upgraded within parking houses. Special occasions which can be hardly managed by level 5. I have taken here one toll gate in China that chaotic traffic before that, which one is automatic toll collecting, which one is manual, and which one is leading to the exit after the toll gate. So it's complicated, and therefore you need also the infrastructure to tell the car that's the way to go. You need this communication to make it more smooth. If not, it will always fail and try. Okay, and there are other situations. If you have a special firework and the roads are closed, you need to inform the vehicle how to behave. We all know when autonomous driving is not working, that is when you have complicated roadworks. And for the roadworks, again, the infrastructure should give information to the vehicles at the spot and inside the cloud. But always at the spot is binding, inside the cloud it's guiding. Okay, different. Binding, red traffic light at the spot is binding, red traffic light in the app is only a guiding that it will stay red for another 5 minutes. And the same is for roadworks. The roadworks needs to be more standardized. Every roadwork looks different. Doesn't have to. if you have their rule how to make it and put a sensor at the beginning of the roadwork, when the car approaches those special area, the sensor is giving all the information about the roadwork data, and then the car knows, okay, I have to slow down 30, then I can accelerate to 50, and then I have to slow down again, instead of just putting a 30 sign somewhere, which is hard to recognize, and then drive the entire way 30, even there is no need to. So with such clever, smart information before the roadwork, car driving will be easier, level 5 will be possible. Another highlight, robotaxi. A robotaxi, level 5 taxi, is nothing else than a taxi. Okay, it's a taxi. Taxi with driver, taxi without driver. As a passenger, you don't care. And we all know that the infrastructure has special requirement for taxi operation. If you go to the airport, you will have a special area for taxi pickup, right? And the same is needed for robotaxi. It doesn't matter if robotaxi is privately owned or if there's a fleet operator, robotaxi need to be exactly same handled as taxis. The big difference is that with robotaxi, people are expecting that demand for taxis, robotaxi, is increasing. And people will rather don't buy a car, take a robotaxi. It will be not that crazy that there will be suddenly everywhere robotaxi in the city. That's not possible, but it will increase. And are those special locations, like end of a concert, end of a soccer game, are they prepared for double taxi, triple, 4 times the taxi amount? Okay, this we should be always aware of. A robotaxi is just a taxi. There will be far more taxi. How to deal them in a shopping center. And my advice is in this business that in some areas, private taxi, right? That I buy a taxi and then, oh, I don't need my car. I buy a robo level 5 car, for, if you want to call it. I buy a car, I don't need it, let it go out and find some business, will lead to a chaotic situation in cities, because the cities are not made and intend to be run in this way. So therefore, some areas, private taxis should be banned. Otherwise, it will lead to collapse, like in big cities. The status quo, it's just a summary here. Road to grid is still at the very beginning, right? We hardly have at the construction site already the information how the construction will look like. But if you have solutions, and if you go into this big data, big cloud, then of course it's a multi-billion US dollar business. You need standardization, especially communication protocol, which data in which sequence and what is necessary. The guiding signs could be added, that you said, okay, this area is level 5 ended. Be careful about the robotaxis, because they are changing the entire infrastructure system, and the road to grid business development is a big business. And if you have the power to influence a new business opportunity for a nation, you should be the lead, right? And there is a huge business opportunity in this road to grid business. So be at the front. Artificial intelligence, it's everywhere. As more data you collect, as more you can do out of it. Collect the data, be autonomous driving, logistic, no matter if private or logistic or transportation, they're all using camera, and based on the camera, they make decision. And this one will be improved if you have this artificial intelligence. Okay, also the communication with the car itself, machine learning for predictive analyzing, the natural language processing. If I drive autonomously in my car and sitting, in front of the steering wheel, I have nothing to do. Now I think, okay, let's work a little bit. Let's write a document on the computer. But then suddenly I need a keyboard. Right? And a keyboard during driving, it will never match no matter how you design the vehicle. And for this one, it's more and more important that you just communicate by language. And this continuous improvement based on your dialect, based on your accent, will be the natural language. So there is AI necessary to make it more comfortable. In summary, yes, it's coming, but we must be careful. The last chapter here, we must be aware that such system can be only the tip of public transportation. It will never replace the public transportation. It's impossible that you take the people out of the underground and to the individual car. And that might also lead then to the problem that there is only limited capacity on the streets, that who will be really allowed to use level 5. Could be adjusted by the price, right? Level 5, if you have a robotaxi, it's just the same price as a taxi right now because there are only limited resources available, or other social imbalance can occur because not everybody can have a robotaxi. That's a fact. Okay, so there will be only a group able to benefit out of this technology development. Because I'm in China, I want to give you some impression about the country, and that's maybe also the reason why you joined this sharing. This one is the port in Shanghai, not far away, where I'm sitting, 1 kilometer away from the bridge. So first, China built a bridge to an island. At this artificial island, natural island, but then enlarged, multiplied, to a deep water port. And this deep water port started operation 20 years ago in 2004. And since 10 years, it's now the busiest container port in the world. So, and between those port and the coast, over the bridge, for example, they're already using since 2019 autonomous truck, 1 lead truck, up to 5 trucks are following. That's the status quo, okay? And this port here is fully autonomous. You will not see any body really interfering. Of course, there are somebody controlling the data center and so on, but there will be nobody touching anymore the container, including container inspection, custom inspection, everything fully in the flow. The gantry crane will unload the truck, put it into the parking lots there, and then from there, there's a handover to the truck itself. So fully autonomous is possible, and it will expand, as we can see here on the real-time example. And probably the last slide here, some examples. We have in China the small delivery trucks, FedEx and others, JD, they're already operating. Okay, and people, they are really used to them. If they are driving on the street, everything is fine. They are just one part of the traffic community like all of us. So it's there. The Sunny here in the middle up, that is battery swap technology for trucks. And it's really widely rolled out already. So China is going those battery swap for heavy duty trucks. It's a big black box behind the driver, and you have a charging or changing station. So the truck drives in, battery out, new battery in, truck continues driving. Right? It's not future. It's coming. And to be honest, it's also a very clever and wise way of dealing with the range anxiety of transportation. And the box is ugly, I agree, right? It's just a box, but at the end, it fulfills the purpose. Exchange the box. Fuel cell, yes, China is testing and don't want to be behind. So there are a lot of fuel cell applications or hydrogen applications. Will it change the world? No, not at the moment, but who knows, maybe 10 years later. So China has a lot of applications already running on hydrogen. We have level 5 buses operating in different cities, different areas, but always restricted. And we have autonomous bus on the lower right corner and with a driver inside, but the driver basically has nothing to do. So that's the status quo in China. I think it's pretty impressive for me as a German living and working right now in China. So maybe I could also share some of this impression with you folks, probably most of you on the other side of the ocean. Back to Robert.
Kai-Marcel, if anyone has any questions, feel free to just hit the react button at the bottom and raise your hand. I have a couple. First of all, thank you very much. Very comprehensive presentation. I recently read a McKinsey report, and there was another one as well, that indicated that currently moving manufactured goods in China takes about almost twice as much resources, or I should say the cost is twice as much as it is in the United States, and about on par as in Europe. Now, Europe has a lot of diversity there, so I was intrigued by that number, and that one of the reasons that the Chinese government is so interested in both automating and electrifying the movement of freight, but certainly automating freight, is to try to close that gap, if you will, in moving freight. So my question to you is, are you seeing examples of freight deployments and piloting within China? My understanding is that there are a few corridors right now where you're beginning to see freight automation, just like we're seeing freight automation in the United States.
Yes, for sure there are corridors, there are test areas, and one example I gave between Beijing and Tianjin, where the really level 5 is tested from the port to the logistic hubs, it's already implemented. So they have it. And one special way in China, and I think it's also the right approach, is they first investing, and then of course the benefit comes years later. What does it mean? That they have, of course, a truck capable, but they are still a driver and maybe a lead vehicle with them. So this kind of situation, you still have a driver, but you're testing. And copying this to the passenger car, the cars you have seen all are ready, right? But the software is not ready. So the hardware is ready, the software is not ready. And once the hardware is ready, they collect all the data. Every car driving there is sending the data to make the system more wise. Right? And that's the same for the logistic. So the trucks driving on the road, they already have, many of them have those sensors and the capability, but there's still a driver inside. And therefore, it's only a question of time till the driver will be picked out.
When you're looking at automation on the on highways, it's a little different than if you're looking at automation in the cities. In the cities, you have C-V2X, the 5G, if you will. The microcells are being deployed within cities. But on highways, it's really a sensor operation tied in maybe to a map. What do you see as the difference between, say, the microcell deployment within cities versus the highways, which are unlikely to have those same microcell, capabilities?
Yeah, as you mentioned already, because highways, they are easy deployed. It's only a network of lines, right? And therefore you can easily predict what is happening. You always have space to divert and so on. And whereas in city you have to, especially in busy cities in Asia, where you have motorbikes, you have mothers with their child, you have even free animals, you have bicycles, pedestrian kids, and so on. So therefore, this complexity needs additional sensoring.
So we're looking at automated ports, which we know China has many of their ports that are automated. unloading containers onto automated freight, and then coming into the manufacturing plants when the finished products are going back to the ports. What you're seeing is a future in which, and a fairly near future, in which that entire process of moving from port to manufacturing with the materials and maybe fabricated products for assembly, then being turned into finished products that are then taken back to ports. Uh, and so you see this as dramatically dropping the costs of freight movement within China.
Yes, for sure, for sure. Once you have such an established route, and then you save everywhere, from the safe diesel of the trucks and the labor costs, and also in production, always the inventory is important, because inventory is cash. Cash you can use for buying machines or buying goods on the way. So also there you have savings, which enhance companies who are switched to this one. The leading will be big companies. Right? If you have big companies where you have really a stable process, every day one truck driving from there to there, that is the most easy way to say, okay, from this one I start my automation, and then later I will spread it to other areas as well. But the cost saving, yes, they are everywhere in every single aspect.
Do
It's
you
also
see
about,
do you see this as fleet companies that are large companies, or do you think this will be driven by manufacturers?
I think the concept about saying, okay, we have level 5 on long distance, and then still manual operation on short distance. How does it really work? For the long distance from point to point, there will be very large operators, only few. Right? They have the fleet, and they said, okay, I plan out the container from there to there, and then from there to there. So there are could be new players, but could be one of the old players who grow up to serve the long distance hub. Now remaining is the first mile. And the first mile, then, it's the driver stands up in the morning, make his daily trips between different plants, and in the evening goes back to his family. Right? So the life of the driver is entirely changing. Now the question is, who is operating this last and first mile? And that could be the classical companies, logistic provider, but more likely it's that the hub provider. Let's assume you have a hub in New York, and this hub provider in New York is sending trucks to Los Angeles, but he can also coordinate the pickup. Right? The hub provider said, I have my own fleet, and if a customer in my area in New York has something to transport, then the hub will pick it up and ensure that tomorrow at 8:30 it will arrive at the customer. Right?
So very
And
much
therefore
like,
this,
so we have inland ports. You look at them as inland hubs within China, but within the United States we have inland ports where the materials go
similar.
to these staging locations and then are taken back. So it looks like a very similar model, and from a regulatory standpoint and framework, it seems that the Chinese government is incredibly supportive of allowing these technologies to both flourish and actually encouraging their deployment.
Yes, yes. As I said, it's a kind of freedom here. I would not say the financial benefits are too huge. At the end, it's the companies going the way, right? Vice versa, if you look at the big car companies, all the picture I have shown you before of this high fancy future LiDAR cars, there is no government-owned cars, right? So they are staying, the government-owned companies like SAIC, FAW, and so on, GAC, they are suffering the same as other companies worldwide. But the new companies who take the risk and push forward, find enough money, they are pushing the technology. And so, but what you need is, beside those entrepreneurship of companies, you also need the government gives you the freedom. And if the government said, sorry, you cannot test your car on a public road, the technology can never evolve. And this, I think, the government here probably has understood quite well, that going from one technology to another one needs the right environment and the right freedom. That's my feeling.
Excellent. Well, Kai-Marcel, you've been very generous with your time. Grateful for your presentation today. And we thank those who came in to attend.